Hello, everybody. So this is the week 16 lecture one. So week 16 is here. Hopefully you have looked at all of the things that you need to be doing this week and have seen my announcement. But what this video is for is to do zyBooks exercises in the week 15 reading and homework, which is your last one. So let's go ahead and jump into that. All right, here we are. And so all of this is covered in the week 15 lecture. So if you come back here and you look at the lecture that's still linked here, week 15, lecture one, and it says file input and output. That's the topic that corresponds to this. And this is just the exercises. So um, in the PowerPoint that I went over, or the lecture slides that I went over, I tried to show this to you as a kind of a two-step thing where we have to set up a print stream and then we could print. But in here, they tried to explain this a little bit differently. So they, rather than just showing you how to print, they're trying to explain the insides of how print stream works. And so we can go through this. So it says programs need a way to output data to a screen file or elsewhere. The print stream class provides several methods. So print stream provides like printf, print line. Okay. Internally, print streams normally places data into temporary storage region known as a buffer. So buffer is, as it says, a temporary storage place. So it's where, like, for example, unrelated to print stream, but like when you're typing things in to read from the keyboard, when you're typing them in, all the keys that you type in are temporarily stored in a buffer. And then periodically, when you use the scanner to read them, it's reading them from the buffer. So it's just this temporary location to store them. This is for print stream, so this is going to be stuff that's printed out to a file or printed out to the screen, but still temporarily stuff is stored in a buffer. So it says system.out is a predefined print streams print stream object. So when you do system.out.println, then you're using a print stream method. Okay, so there's an animation here. We can look at it. So exercises. Characters written to system.out are immediately written to a system standard output. Well, above here, what we just talked about was they actually go to a buffer first. So they just want to see if you understand that there's kind of this intermediate step. So characters written to system.out are immediately written to a system standard output. False, they go to a buffer first. To use system.out, a program must include the statement import java.io.printstream. No, because it's already defined for us, right? We've never used this before. Well, until we learned about files, we never used this before. So we've been printing stuff to the console all semester. So obviously, we don't need that. Various standard data types are converted to character sequence by print and print line. Yeah, like when you print an integer, right? That works. So how does that work? Well, they have to be converted to characters, right? Internally, they're just bits representing a number, but that number is not the same thing as like the characters that are printed out. Okay. Input stream, system.in, throws clause. So we did go over this. So an input stream can be set up for a file so that we can read from a file. System.in is an input stream that corresponds generally to the keyboard. And throws is having to do with exceptions, which are errors. And so we add this text throws IO exception to a particular place. You can see where it is here, that it goes public static void main string args. That's always there. And then normally right after that parentheses is this curly brace. But throws IO exception is now there. So that allows us to do this without properly handling the exceptions that could occur. Um, yeah, all right. System.in is a predefined input stream associated with standard input. Yes, predefined. A program must import the input stream class in order to use system.in. No, just like for the print streams, we've been printing from not printing. We've been reading from the keyboard all semester, right? We never used input stream until recently. A read from system.in will read bytes from a buffer filled by the operating system. Sounds right? So when you type keys on the keyboard, they go into that buffer and then we read them. The input or the throws clause for using an input stream is throws input exception. I mean, that's just wrong, right? Like it was IO exception. All right. So this is actually Java util scanner and then showing how to use scanner. We don't need to do that because we've, done that a million times. What class has methods to extract strings, integers, and other types from an input stream? Scanner, right? We use next line, next int, next double, right? To get those things from the keyboard. What is passed to the scanner's constructor? An input stream. So normally we say system.in, but up above here, they told us that system.in was an input stream. Okay. So that's all just kind of, what is what, like almost vocabulary. Um, this is actually, I think this section might be a little bit not tough, but um, there's like, I think a lot here. So we've used printf before to format our text. And I've explained this before as well, but it doesn't hurt to do it again. Printf, woo, printf is a very old-fashioned uh, printing function that exists in many programming languages. So there's a printf in Java, there's a printf in C++ that you can use. There's a printf in C. The MATLAB programming language has a printf, even though it's completely unrelated to C, and so on. A lot of programming languages implement printf because they assume, you're gonna maybe you write some code in Java today, you might be converting some old code into Java, right? You're converting old code into Java. Do you want to rewrite the printf statements or do you just want to use them the way they are, right? So that's why it kind of looks a little bit different that like with these kind of placeholders to fill in the variables in compared to like the rest of the stuff we do in Java. It's because it doesn't come from Java. It's an older type of function. But anyway, like we know how this works. So you do system.out.printf and you say the, and then you put an entire string here. So it starts with double quotes, ends with double quotes. And then if you need to insert variables anywhere in this sentence, then you use placeholders, right? So this one right here, the %s is going to mean we're going to be putting in a string there. And percent, the %f, that's going to be a floating point value. And the %d is for a whole number. Now, like, why is d whole number? I think they mean like decimal, like base 10 number, but not decimal like a decimal point. They mean decimal as in DEC means 10. So %d is integer. Just remember that. %f is floating point. And, %s is string. That's not that hard to remember. And then, so if you included three placeholders here, like first placeholder, second placeholder, third placeholder, after you type the whole string that you want to print, you do comma, and then however many variables you need to insert. So this had three placeholders in the text, so you need to give it three variables to fill into those places. And so they included account, total, and years. So account is going to go into the first placeholder, total is going to go into the second placeholder, and years is going to go into the third placeholder. So, yeah, we've used this before though, right? So what can we do? Well, here are the different types of things that you could use for your placeholders. So %c for a character, %d for an integer value in decimal, %o for octal, which is base 8. We don't use it basically ever nowadays. %s, f, Yep. Why can't I say words? Percent H is hexadecimal. Hexadecimal is used because if you do uh, color picker, if you pick a color, you get something like this, or this down here, for the color code for a particular color. And basically, that's going to be 6 digits organized into two. And so the first two digits are how much red to use. It's 155, but written in hex, that's 9B. The next one is green, 36 in hex, but 54 in regular numbers. And then the blue, 9B here, which is again 9 or 155 here. And so this is how you specify colors in like things like web pages. So like if you were making your own web page and you needed to specify like what color we wanted this box to be, generally you would be specifying colors in hex. And so that's actually a good usage of hex. Like we could write a color picker right now just by you pick a red, green, blue value between 0 and 255. And then if we print it out as hex, we're going to get this if we print the red, the green, and the blue side by side. So hex is useful nowadays. Percent %f is for float. That's mostly what we've been using printf for. Printf we used when we wanted a specific number of decimal places. Percent %e is for also for floating point numbers, but you want to put it in scientific notation. Percent %s for string. And if you need to type a percent, you can type it with percent, right? Because we're using percent for this other meaning, you have to do something special when you actually want a percent, when you actually want to print a percent. Then it has percent %n, which is the new line. But you'll notice up here, this is how we've been doing new lines, right? \n. Down here it says use percent %n, but we've been using \n for new lines, and they both work. All right. So looking at this, we'll try to get down to the important exercises later. But what do we got? So string name Alice, double GPA 3.5, int age 20, right? So if you were to present this, we have percent %d, that's an integer, percent %s, that's a string, age, and then name. So we're going to fill in the age first, which her age is 20, and then we're going to fill in the string with the name, which is Alice. So it's going to print 20 Alice, right? It fills in the age and the name into those locations. If you wanted to print this, how would you do it? Well, this right here, the 3.5 is the GPA, right? But 6 decimal places is what you get by default when you use percent %f. So percent %f, I wasn't trying to select it, I just wanted to highlight this. Percent %f will present a floating point number to 6 decimal places by default. So this is going to present, this is going to print 3.50000 6 times, or actually 5 times, 6 decimal places. And then to actually print a percent, remember that what we learned was that you had to type 2% symbols in a row. So 2% symbols in a row to get one output, then a space, and then percent %d, and then percent %d is an integer value. So it's got to be this middle one, right? How would you print 2021? Well, the age is 20. So you could present, you could, I don't know why I keep saying print or present, but you could put in percent %d for two numbers, right? But they all have percent %d, percent %d, percent %d, percent %d, percent %d, percent %d. But we want to print 2021. And so if the age is 20, age plus 1 would be 21. So that's how you would do that. Floating point values. There's a lot of information here that's kind of new, We'll ignore it until we get to the exercises that actually use it. So the ones that we've used so far, um, the ones we've used so far are these two before the F. And so like dot two here means we want to round it to two decimal places, right? We learned that. And if you did lab 15, then you'll know that the number before the decimal point, if you put a number before the decimal point, is going to be how much space is reserved horizontally for the number that you're trying to print. So this would be reserving 7 spaces for the number in the output and rounding everything to two decimal places. And so this is an example of how it might look, where um, there's two decimal places here, but there's actually 7 spaces horizontally reserved for that number. Okay. Now, if you do it this way, dot 4F, that's 4 decimal places. So you get 4 decimal places, but we did not reserve any particular number of places. So that's why the number is just all the way on the left side here. 3.4, well, the 4 is how many decimal places. So you have 4. The 3 is how many spaces to reserve, 3, but you don't really see that because it's more than 3 already. And the E means scientific notation. So this is times 10 to the 1, essentially. If you put a plus before the F here, what that means is we always write the sign. So if it's negative, you put a minus sign, and if it's positive, you put a plus sign. Normally, you would not have a plus here, right? When you print out 12.34, it would just print 12.34. It normally would not print a plus. But if you put this plus here, it will always print the sign. And if you put a 0 like this before the number, the 2 means 2 decimal places. The 8 means reserve 8 digits. And the 0 here says reserve, or sorry, fill in all the extra space with zeros. So if we count the spaces, 1, 2, 3, 4, 5, 6, 7, 8, you'll see that it did reserve 8 spaces. But in this example up here with 7 spaces, the spaces were blank. If you put the 0 here, then it fills in those blank spaces with zeros. That's just to help you line things up visually. If you're printing a bunch of numbers, it can be helpful. All right. There's also other flags other than the plus. Like a minus left aligns the output. A plus adds a plus on every positive number. And 0 pads the output with zeros. So we saw the zeros and we saw the pluses there. All right. Well, I guess this is actually useful. So if you printed this, what would it print for this number? Well, this says 5 decimal places, right? So if we just copy this whole number, we see that it's 1, 2, 3, 4 decimal places now, right? So the fact that it's dot 5 means we have to add a fifth. And the plus here means that we're always going to write the plus sign if it's positive, so you have to add a plus. Okay. For this one, again, I just copy pasted the number to start with. This is E. That means floating point format. That means scientific notation. So scientific notation means instead of writing 45.1342, you have to move the decimal place 1 place to put it there. And then this would be, I'm going to write it not in scientific notation yet, times 10 to the first power now, right? Um, that's kind of what we would have. But the 3 here means 3 decimal places, so you'd have to chop it down to have 3 decimal places. And then also, this is not how we do scientific notation, so you have to look up here for an example of that. So it's E plus if it's a plus power, and then 2 digits for the exponent here. So I'm going to copy that. What? Why did it? So that would be correct because the 0, 1 would be times 10 to the 1. And I think the rest of it is correct. Okay. Do this one. What does this mean? 2 decimal places. So let's chop it off at 2. 9 digits, but we should fill in the spaces with zeros. So how many digits do we have so far? 1. Whoa, why? Um, what? Stop. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9 digits, 2 decimal places, and the extra digits are filled with zeros. All right. Integers are going to be a little bit simpler than the floating point numbers that we've been doing. They still have the same flags. We can use plus to write pluses, zeros to fill in extra digits. The width still has, there's no decimal points because if you're printing an integer, there is no decimal points, right? Let's go here. So this number is negative 713. And so this says reserve 4 spaces, which we already have 1, 1, 2, 3, 4. Cool. The 0 says pad it with zeros, but we already have 4 digits, so we don't need to add any more. You count the negative there. The plus says always write the sign, but we already have the sign, so there's nothing to do here. We have this. D is integer. Now this is 5 digits, but we have 1, 2, 3, 4 so far. So we need a 5th digit. And the 0 here indicates that we should fill in the extra spaces with zeros. So we'll have to put a 0 here. So we'll have to write 713 this way to make it 1, 2, 3, 4, 5 digits wide. All right. So this says 2 spaces reserved, but this is already more than 2, so we ignore that. Put the extra spaces 0, but there are no extra spaces because we've only reserved 2 and it's already like 4. And fill in the sign plus or minus, but that's already there too. So this is really kind of redundant. It's just going to print negative 713. All right. Strings, you could do a width, which is the minimum number of characters to print. So like this is saying print at least 20 characters. Precision, so that'd be like the dot number, is the maximum number of characters to print. So that way you could use that for like if you have like if you're filling in somebody's name in like a form, if their name's too long, right, then it's not going to fit in the space, and so it's going to ruin the formatting of the sentence when the sentence gets longer. So you could use the precision here to kind of cut off extra spaces. Um, yeah. And then you could left align it or right align it, which means like if you had 5 letters in a 20 letter space, you know, is it 5 letters on the left followed by 15 spaces, or is it 5 letters on the right with 15 spaces before it, right? So is it on the left or on the right? By default, it's on the right, but we can change that with the negative. Cool. And so you could use these kind of spacing things to make nicely formatted tables. All right. So if we printed testing and we reserved a minimum of 4 spaces, that's the width, then it's just going to print testing, right? 4 is not the minimum, sorry, 4 is not the maximum number of letters to print. 4 is the minimum, right? So the width is the minimum. The precision, which is like a dot, and then the number is the maximum. So this should just print testing. Now this is testing with 8 spaces reserved. So how many are there? One, two, three, four, five, six, seven. So there's seven. So there's an extra, we need to have a minimum of 8. So where is it? Well, the space should be at the beginning because we are not aligned to the left. Because we need, like, if you wanted it aligned to the left, you need an extra negative there. All right. Testing. Dot four, that says maximum of 4 letters now. So which 4 get cut off? Well, it should be one, two, three, 4. So ing should get cut off. Dot 10, that is the maximum number of letters, but not the minimum. Whoa, everything. Okay, what's going on here? This says left align, 8 spaces. So this is one, two, three, four, five, six, 7. So last time we needed 8 spaces, we added the space at the beginning. But because this is left aligned, that means we want the letters all the way on the left. We add the space at the end. So this is going to print testing with the space after it. Now, this is confusing here, 1, 2, 3, but remember that you can have any extra text here you want. So the 1, 2, 3 here is not part of the string. It's just, I mean, it's not part of the formatting. It's just literally the letters 1, 2, 3. All right. We've never used this before, but you can do system.out flush, and that can make the text that you're writing print out immediately to the screen. That's important because sometimes you can try to print like several lines at a time, and we know that those go to a buffer. They're not immediately printed out unless we make them immediately printed out. Um, what can happen? We haven't seen it happen this semester, but what could happen is, what if you were trying to do some calculation in a for loop and you were trying to print out status every time through the for loop? Um, what could happen potentially in some situations is that, like, maybe your loop is going to loop 1,000 times. Well, what could happen is your loop loops 1,000 times, and when 1,000 times are all done, then all of the text is output to the screen all at once instead of like line by line. So maybe you wanted it line by line, but you don't get it line by line. You get it 1,000 lines all at the same time. And so sometimes you need to add a system.out flush in your code right after you print something just to make sure that it actually ends up on the screen now instead of later. All right. Now, what does it say about flush? Um, where? So flushes the stream's buffer contents. It writes the contents of the buffer to the computer screen. Most Java implementations make system.out flush when a new line character is output. So print line has a new line, right? So would this be flushed? No, because it's not print line and there's no backslash in. But would this one be flushed? They just told us right up above that the way Java generally works is that if there's a new line, it's flushed. So print line prints a new line. So yes. Line C. This is just another regular print again. Um, but this would not normally be flushed, but the next line is a flush. So I think they mean, like, I think they want us to think about these together because D is the next line after that. So normally, but would not be flushed, but they flush right after it. So I think, yeah. Oh, no, they didn't want that. They did not want us to include that extra line. So C does not flush. Do not look at that flush. I don't know why they put it there if we're not ever paying attention to it. And then line D is here. Both live and utter it. Backslash in. Backslash in is a new line, so it should flush right after that. All right. So these exercises could take a while. Um, we just got to figure out how they work. We'll do some of them. So this is just predicting things. Now, I will say this, if you get stuck on any of these, you could always just go to Eclipse and put in the code, right? And get the output to copy paste here. Anyway, 853. So percent dot two means it reserves two spaces, but it's already three, so we don't care. And then we print it again with four spaces. So this reserves four spaces, but 1, 2, 3 is what we have. So there'll be an extra space at the beginning. And then an enter because it has another backslash in. Cool. We got a number, or we got two numbers. So 31.4124. And the dot three means three decimal places. So that. The dot five means five decimal places for the other number. And it's currently four, so we have to add an extra. And then enter. I'll just skip one. We'll go to 4. 903. But this is five spaces. And the 0 here means fill them in with zeros. So it's currently 3. So we'll add a 0, 0 to the beginning to meet the format. Next number is 7847. Dot 2 means two decimal places, which we already have. 6 means reserve six spaces. So 1, 2, 3, 4, 5 is what we have. So we need one more. And the 0 means fill it in with a 0. So that means 0 there. They both have new lines. All right. Sam, Harry. All right. Sam, how do we do it? Well, oh, also there's an asterisk here, which is confusing, but that's literally just an asterisk. Um, so the format here says string, okay, 7 spaces. We only have 3, 1, 2, 3, 7 spaces. And what does the line mean? Means left aligned, right? So I don't know. This isn't, yeah, this is string. Left aligns the output. So what that means here is that when we make this 7 spaces, well, sorry, this one, 7 spaces, it's either going to be 1, 2, 3, 4. So it's 1, 2, 3, 4, 5, 6, 7. Or it'd be 1, 2, 3, 4, 5, 6, 7, right? This is on the right or right aligned. This would be left aligned. So the negative here says that it's left aligned, which is this. So this is 7 spaces reserved for Sam, left aligned. Next one is Harry, same thing, Harry, RRY. This is 1, 2, 3, 4, 5. So 6, 7, and then the asterisk. And so what they want you to kind of notice here is that um, using this feature to control the width at 7 spaces means that we can tell that these asterisks are going to be vertically aligned because we know that we have 7 characters reserved ahead of them. And that's how you help keep things aligned, is by controlling the width of the printing there. All right. Let us do these. So start. What do we got? Integer amount calculated is and double length are read from input. Okay, they already did that. Output the following. Amount calculated as a decimal integer valued followed by percent. uh, length as a floating point value in scientific notation, followed by percent, and length as a floating point value, followed by percent. Okay, so they want to see if we can use these. So system dot out dot printf, and what are we printing? So the first one is a amount calculated, which is an int. So int is percent %d. That's a decimal value followed by percent. So percent %d prints 93. But in order to print the percent symbol, you have to type percent. So percent. And then each output ends with a new line. So that's \n like that. And then we want to fill in amount calculated. Okay. So that's a little bit awkward, right? This is the placeholder for the integer. This is printing a percent, and this is the new line. All right. So next one, I will just copy the entire line. And the next one we're printing is length as a floating point value. So let's get rid of everything in here. So what are we printing? So floating point value in scientific notation. So %f is floating point value. %e is floating point value in scientific notation. And then followed by percent, again, we'll have to type percent to get percents, and then \n for the new line. And this is supposed to be the length. And then for the last one, it says length as a floating point value. So we just change the E to an F, and that's the regular floating point value. So hopefully we did these right. Let's find out. If we got them wrong, we'll see how. We did not get them wrong. We got them right. Cool. What's the next one? We can just do all these. Double box weight and integer box length are read from input. Output the following. Box weight with the zeros as padding. All right. So we have system dot out dot printf. What are we printing? Box weight with the zeros as padding. So the weight is a double. So that'd be like percent F. But then it says zeros as padding. So that would mean the flag is a 0. A minimum of 6 characters. So that's a width of 6. So that's 6. 2 digits following the decimal point. So that's .2. So 0 for the zeros at the beginning as padding. 6 for 6 characters wide. .2 as 2 digits following the decimal point. And then we want that on a new line. So I think we have to do \n. And then after our string is done, what are we printing here? I think we're printing the box weight. Cool. Next one, box length left aligned. So we're doing another system dot out dot printf. What are we printing? So left aligned, that's a dash there or negative, whatever. Minimum of 6 characters. So then we have a 6. And then its length is a integer. So that's D. So left aligned, 6 spaces, integer. So that's the integer. And then what do we want? I guess we just need a new line at the end. So \n. And here we're printing what? I think we're printing the box length. So I think that is both of the things that they asked us to print. Uh-oh. Oh, I did not capitalize the W in weight. Cool. Oh no, we got them wrong. Oh, I forgot the percent. I forgot the percent -6D. So without that, it just printed -6D, which is obviously wrong. So I forgot the percent. Try it again. All right, now we got it. Last one. String num value is red. So it's called num value, but it is a string. String, not a number. Keep that in mind. What are we doing? Um, Output printed string. Okay. So system dot out dot printf quotes. What are we printing? Well, first of all, we're printing printed string. So let's add that in. And then it says followed by num value with a maximum of 6 characters. Maximum of 6 characters. So we know that like basically you can put a number and then dot and then another number. So the first number is the minimum and the after the decimal point is the maximum number of characters. So if we want a maximum of 6, that's dot 6, and we're printing a string, so S. And then it says, and then space is printed. Space is printed. So like that. That seems right to me. If we get it wrong, then we will um, fix it. But right now, printed string is printed, end with a new line. So we need \n in there. And then after the comma, we need num value, I guess. And there we go. So we'll try it. If we get the spacing wrong, we'll fix it. But we did not get the spacing wrong. Yeah. And so you can see what the maximum of 6 characters did. Like if you type in something long, then it just chops it down to 6 to fit 6 characters. All right. So that took a while. We didn't actually do any printing to files yet. So the next section here is streams using strings, and then we'll actually get to file output. So I will I will film a new video for this, but I feel like this one's long enough without getting into this topic. So it's I think we're at like 43 minutes. So yeah, we'll stop here. All right, I'll talk to you guys later. In the next video, we will finish this stuff out.